Okay, discovery of electrons. An electron was discovered by cathode ray discharge tube experiment. Say, cathode ray discharge tube. Now, I have already told that there are a device called cell. In the cell, we have two parts, which we call as a electrode. Electrodes are the metal rod deposited in a cell, and a cell is a device which can convert one form of energy to another form of energy. Now, these cells, which we call, are of two types. One is electrochemical cell, which can convert chemical energy into electrical energy, or another one is electrolytic cell. Electrolytic cell are those cells which can convert your electrical energy into chemicals. So, based on the difference of the cell, we have two types of electrode. One electrode which can join with the negative terminal, that we call as an anode, and join with the positive terminal, that we call as a cathode. This is in case of electrochemical cell. Whereas in case of electrolytic cell, those which undergo oxidation, that is anode, and those which undergo reduction, that is your cathode. Like this one, anode and cathodes. So the symbol of anode and cathodes is differ. In case of electrochemical cell, anode become negative and cathode become positive. Whereas in case of electrolytic cell, anode become positive and cathode become negative. So like this one, cathode ray discharge tube. Here, this tube produce cathode ray, and here electrical charge become discharge. So that is why this tube is called as a cathode ray discharge tube. So in the cathode ray discharge tube, now is in the result of this cathode ray experiment, I have already told that cathode ray start from cathode and move towards the anode, and it is not visible, but by using a fluorescent or phosphorescent materials, it can be visible. When cathode ray falls on the wall of this fluorescent material, it gives a bright spot. So again, in absence of electrical or magnetic field, this ray travel in a straight line, but in presence of electrical or magnetic field, the behavior of cathode ray are similar to that expected from the negatively charged particle, suggesting that cathode ray consists of negatively charged particle, and later on J.J. Thomson called this cathode ray as an electron. Again, the characteristic of cathode ray does not depend upon the material of the electrodes or nature of the gases present on the tube. Now, let us see about the charge to mass ratio. Charge to mass ratio of an electron. So, this is what we can see it according to your books. The measurement of mass ratio, of an electrical charge to the mass of an electron by using cathode ray discharge tube and applying electrical and magnetic field perpendicular to each other, as well as the path of the electrons. So that means if you want to measure E by M ratio, now for that you need to do it. So you can see in page number 28, figure number 2.2 of your textbook. So on the way of cathode ray, we applied magnetic and this electrical field, and just by passing this field, we keep a fluorescent screen. So when cathode ray passes through this magnetic or electrical field, then some of the rays bended towards A and C, and some rays are in the B. So when you adjusting this magnetic field or electrical field, then all the rays falls on B. Remember, it means that it will goes in a straight line, and if you make the adjustment, then the cathode ray may reach to either A or C. That means deflection would be either on A or C. So this is what we have seen in the picture. And then the amount of the deviation of the particles, that means how much deviated from B to A, or what is the angle between B to C, that is there. The amount of deviation of particles from their path in the presence of electrical or magnetic field depends upon, that means these angles depends upon, number one, the magnitude of negative charge of the particle. Greater the magnitude of charges of the particle, and greater is the interaction of the electric and magnetic field, and thus greater is the deviation. Suppose the negative charge produced from this experiment, if it will have large number, then the attractions between the negative charge and electrical or magnetic field becomes more, and thus deflection become more. The mass of the particles, lighter the particles, greater is the deflection. That means lighter the particle, then greater is the deflection. That means deflection is large, then that means that particles have light, that means the mass of the particle is less. So this is what we have seen here. Again, the strength of electrical and magnetic field, the deflection of electron from the original part increases with the increase in the voltage across the path electrodes or strength of the magnetic field. So if voltage increase, then this deflection become increases, or if the strength of the magnetic field is increased, then the deflection become increases. This is what we can conclude in the charge to mass ratio. Now, when only electrical field is applied, now instead of applying both electrical and magnetic field, if you applied only electrical field, the electron deviate from their part and hit the cathode ray tube at the point A. So the cathode ray may hit to the point A only when the electrical field is applied. But if you apply only the magnetic field, the electron strikes, that means the cathode ray strike on the cathode ray tube at the point C. So this is what we have seen. When the electron deviate from their path, and then both electrical and magnetic field is applied, it is possible to bring back, and the electron go and hit to the screen at the point B. So from this we know that E by M ratio, that means this charge of the electron divided by mass of the electron should be 1.7588 to 0 into 10 power 11 coulombs per kg. So this calculation is not there, just you need to by heart the value. Here M, E is the mass of the electron, and E is the magnitude of the charge of the electron, and C is the coulomb, and this is what we have known in this charge by mass ratio. Now we'll see discovery of proton and the neutron. As we have already know that atoms are of electrically neutrals. Atoms जो electrically neutral है बोल के हम लोग already बोल चुका है. So if electron is there inside the atoms, तो atom का अंदर में electron हो गया. That means that electron carry negative charge. Again, the mass of electron is negligible as compared to the overall mass of an atom. This indicates that there are some other materials other than electrons in the atom. So scientists start discussing by using the cathode ray, same cathode ray, but in this case your voltage become lower. At the first case, for finding out electrons, we have taken high voltage, but in case of proton, we have taken low voltage. And in the previous case, we have taken low pressure. Now pressure become increased by putting some more air again into the discharge tube. And during this case, when low voltage is applied in the high pressure condition, then we get a new type of ray which move. This time the ray start from anode and move towards the cathode, and this ray is called as a canal ray. तो एनोड से शुरू होता है, कैथोड के तरफ जाता है, तो दिस रे हम लोग क्या बोलता है, बोला canal ray. So canal ray are of ray opposite to cathode ray. So this canal ray, if you pass towards the electrical field, it moves towards the negative plate. That indicates that canal ray carry positive charge. So first point for the characters of canal ray: unlike cathode ray, positive charge particles depends upon the nature of the gas present in the cathode ray tube. So this, how much amount of this canal ray will produce, that depends on the nature of the gas. And these gases are simple positive charge ions. Then the charge to mass ratio of the particle is found to depends upon the gas from which they originate. So E by M ratio should be depends on the nature of the gas. And some of the positive charge particles carry a multiple of the fundamental unit of electrical charge. The behavior of this particle in the magnetic or electrical field is opposite to that of the electron or cathode ray. And later on, this canal ray are called as a protons. So the smallest and lightest positive ions was obtained from hydrogen, and hydrogen ions we call as a proton. So that is why this particle is called as a proton. Now inside the atom, we know that there is two subatomic particle, one which carry negative charge, and Thomson give that one as a electron, and another one which carry your positive charge, which is obtained during the time of canal ray experiment. And this positive charge particles was characterized in the year 1919, and this we call as a proton. And now this is the discovery of electron and proton. But when we added the mass of electron and mass of proton, we did not get the actual mass of an atom. But we know that the number of proton and number of electrons become equal. Hence, we can explain the electrical neutrality of an atom. And due to less of mass, again, scientists have studied about it, and then Sidwick feel that by bombarding a thin sheet of beryllium by alpha particle, that means in the thin sheet of beryllium you take it, through that alpha particles hit on this beryllium plate, then electrically neutral particles having the mass slightly greater than that of the proton was emitted. During the time, Chidwick got that one electrically neutral particles, but mass having nearly get or slightly greater than proton, he got it, and he give this name as neutrons. So neutrons are the electrically neutral particles present in an atom. So this shows that inside the atom we have three subatomic particles, First one electron, second one proton, and third one neutron. So how we can find out electron, proton, neutron? That history you need to understand it. So in the first one, what I have already told, that electrons means that from the cathode ray experiment we got. And during this time we need two conditions. One is low pressure and high voltage. For the neutron, for the proton, we got this canal ray experiment. Same discharge tube we use, but only the pressure is more and voltage become low. In the case, ray comes from the anode, move towards the cathode, and it will have same properties as the cathode ray. Only the difference is about the size. Only the charge. So it will have electrical and magnetic field defect opposite to cathode ray. And later on, Sidwick produced the neutral particle by bombarding beryllium sheet by an alpha particle. During that case, he got a neutral particle having the mass slightly or larger than proton, and he give this name as a neutron. So this is what about the discovery of these subatomic particles. After then, beta, which is of negative charge particle. Beta is of negative charge particle. So beta ray have minus charge 1 units, and it was represented by electrons, whereas gamma ray are of neutral in charge and highly this gamma ray particles have high penetrating power. So you need to recall all this. Now let us see it, the properties of alpha, beta, gamma, which I have already told that any emission means that continuous emission of light from a substance we call as a radioactive substance, and the phenomenon is called as a radioactivity. During the time of radioactivity, the radioactive particles is kept in a lead block, and the ray which comes out from the lead block is passes near the electrical field. During the time, one of the ray move towards the negative plate, another ray will move towards the positive plate, and the remaining rays will move in a straight line. Those which move towards the negative plate we call as a alpha particle. Alpha particle are of highly energetic and have +2 charge and 4 atomic mass unit. Alpha particle is represented by helium, which I have already told that, and alpha particle is represented by helium. And beta rays are of negative charge particle similar to electron, and that is why beta particles are represented by E. And the gamma ray are of highly energy radiations like X-ray, and it is neutral in nature and do not consist of particles. As regarding penetration power, alpha particles have least penetration power, followed by beta. Beta means 100 times of alpha, and gamma means 1000 times of alpha. So gamma ray have more penetrating power than alpha ray. Now we will go to the Rutherford model of an atom. Okay. So for today, we'll discuss up to this Rutherford model. Will be discussed on the next day. That means tomorrow. You tell to your friend to join in time regularly. Okay. Today, number of students means I think you are alone. So for today, up to this only, we'll discuss. Thank you.